The IEEE Hardware Team is a group of undergraduates who are organized to compete in the IEEE Southeast Con competition in April of 2015. We're a group purely made of passionate undergraduates who are all unpaid, who are dedicated to building advanced robots.
So before last year, the IEEE Hardware Team was really just a group of students from the Machine Intelligence Lab that would get together 2 weeks before the competition, and they would throw together something that just barely works. And that was really all it was, because the competition was considered simple compared to some of the other competitions that the lab competes in, like the RoboSub and RoboBoat. But last year, our previous leaders, Mason and Khalid, decided that they wanted to take advantage of the fact that the competition is relatively simple, and they said, let's not do that. Let's take the robustness of the robots that we're building to the next level. And, instead of following the lines and sort of brute forcing the competition, we would do something more advanced. So we skipped the lines, and our robot was finishing runs in 30 seconds while other teams were finishing in 4 minutes. And so that was unprecedented at this level of competition. We raised the bar for everybody else, and that motivation, that drive has carried through to Jake and I as the leaders for this year.
Currently, our principal goal is to build the most advanced possible robot that we can build within the budget allocated to us. And by pure coincidence, this robot is able to compete in the IEEE Southeast Con competition. And the reason I say that is because we chose to build a more complex robot for the sake of building a more complex robot, to train our engineers in extraordinarily rare skills, things like computer vision, point cloud analysis, nonlinear controls, and probabilistic robotics. Topics that are simply not covered in an undergraduate curriculum. You will very rarely find an undergraduate who, leaving their bachelor's degree, can speak at length about machine learning and its importance in applying computer vision. And even more rarely will you find an undergraduate who's actually done it. Which is why our goal, in principle, beyond just building a robot, is to train our engineers to be skilled members of the workforce, members of the research community. When we build robots, we're not just putting metal together or writing code. We're teaching people to be skilled engineers. We're building the future and creating a structure of innovation around students.
So I really like getting involved with IEEE this year because as a computer science major, there's a lot of things that we don't learn in class, and a lot of it's very theory-based, so it's been really cool to be involved with a lab that teaches you application, and I've been able to see a lot of interdisciplinary work come together. And it's just cool to see something you learn and then immediately after see the effects of the robot arm moving, or to see it being able to process an image that you put into it. It's really cool, and it's a really rewarding experience.
I, like many aspiring engineers, once struggled with the question, when am I going to use this? How will this apply to my career while I was taking my classes? IEEE has changed that. Working on the IEEE robot, I have found direct applications from what I'm learning in my courses to the robot. So finally the question, when am I going to use this, has an answer. And it's not someday, it's Saturday.
The best thing about MIL when freshmen and sophomore join is that they oftentimes come in without any experience, but they learn. And more often than not, at the end, their actions exceed their own expectations.
The IEEE Hardware Team at the University of Florida has really given me a chance to directly contribute to an ongoing competition and just get right in there, especially as a first-year student who just arrived on campus. The concepts that are employed in the competition are not necessarily ones you learn in the classroom, and as a result I'm able to rely on the wisdom of my team members and the growing compilation of open source robotics information that's on the internet that I can look up and use to solve problems and implement solutions. One of the most exciting things about this competition is that by the end of it, I will have contributed to that compilation of open source robotics information, and maybe someday someone will Google how to do a transform or path planning or something like that, and they'll see how I solved a problem and decide, you know what, that's an interesting way, maybe I'll use that, but a little bit of something of my own, and continue the development of open source robotics worldwide.
With your support, we can purchase more advanced sensors, better actuators, better equipment, better materials, and we can build better robots. But the reason for that isn't just so that we can build better machines. The reason is that when we do more complex things with better hardware and better equipment, we produce better engineers. And while we often try to remain on the bleeding edge of technology so that the skills we produce here are useful in industry, we often have to make compromises where we're scavenging parts from destroyed cars, refrigerators, and old printers. We want to do better. And the reason for that is that when we do better, we get better engineers. With your support, we can train our students to have skills that are useful in industry and in the modern research environment. Thank you very much for your interest and your support. If you or anyone you know would like to participate in our team, I invite you to contact us to learn more. The information to do so is in the description of this video. Once again, thank you very much for your support, and I look forward to hearing from you.